All right. So it looks like we're all back. No confusion about daylight savings time, I see. Very good. All right. So we're going to carry on with our discussion about foreign exchange. This is still chapter 11. It's a very long chapter, a lot of important topics. So we'll just continue where we left off. So I think where we left off was actually we're looking at how exchange rate changes affect the economy. And so what we're going to do now is introduce a very important idea that you might not have thought about before, but if you recall from any other economics classes you've ever had, we often make a distinction between real and nominal variables. So let's just quickly review that for a second. So what happens in economics, whoops, what did I do here? Real versus nominal variables. We have to make a distinction in many cases in economics between these two ideas. And so what's different between them is that real variables are adjusted for inflation, while nominal variables are not. Now, nominal variables are the ones we actually observe in the real world. So, for example, if a bank, for example, pays a 5% rate of interest to its depositors, and the rate of inflation is 2%, then we can make the following statements. Number one, the nominal rate of interest is 5% because that's the rate that you actually are being paid, but the real rate of interest is 5% minus the inflation rate of 2%, which equals 3%. Okay, so in other words, what we did here is we took the nominal rate, subtracted off the inflation rate to come up with what we will call the real rate of interest. Okay, and the real rate of interest represents how much our purchasing power will increase by holding money in this bank. The nominal rate only shows how much our balance will increase. Okay, in other words, the way to think about it is that, for example, if you kept your money, actually, let me just go back to this for a second. The real rate is an attempt to measure how this affects your purchasing power. The nominal rate just tells us how much our dollar balance will go up. And they're not, of course, the same thing. So nominal is 5, real is 3. So for example, if we deposit $1,000 in this bank account, for 1 year, at the end of the year, the balance will be $1,050, but her purchasing power would have declined by $20. In other words, 2% of 1,000, so that the gain in purchasing power is only $30. Okay, so in other words, yes, we have $50 more in actual money, but because our purchasing power has fallen by 2% or $20, the gain in purchasing power is actually only 30. So that's why we would say that we have a 3% real rate of return, in the sense that our purchasing power has risen by only 3%, not 5%. And that's because inflation eroded our purchasing power by 2%. Now we can apply this idea of real and nominal variables to a lot of different types of situations, like interest rates. We could also apply this to gross domestic product, for example. But it turns out we can also do this with exchange rates. Now, what's interesting about this is that when we adjust an exchange rate for inflation, we actually have to take into account the inflation rates in two different countries. So that, for example, if we're looking at the exchange rate between the dollar and the pound, in order to convert that exchange rate from real to nominal to real, we have to take into account the inflation rates in the United States and in the United Kingdom in order to come up with what we will call a real exchange rate. So we know already that the price of one currency in terms of another is referred to as an exchange rate. And since this is measured without adjustment for prices, it is a nominal variable. All right, let me just update that a little. Any adjustment for prices, in other words, it is the nominal exchange rate. Now, the real exchange rate equals the nominal exchange rate, but adjusted for the price levels in both countries. And that's what makes this unusual among all the different variables that can be turned into a real version. This is really the only case where we need two different inflation rates in order to make that happen. So it's a little bit more complicated than what you would see with some of these other situations, like converting a nominal rate into a real rate. It's very simple. You take the nominal rate of interest, you subtract off the inflation rate, and what's left over is the real rate of interest. Because of course this is all done in dollars, we don't have to worry about exchange rate. But when we start looking at exchange rates themselves, then all of a sudden, converting from nominal to real requires two different inflation rates. Now, here's what's going to happen too. Once we actually make this adjustment, the units in which we measure the real exchange rates will be very different than the units in which we measure nominal exchange rates. Okay, now that's different. With the example we had a few minutes ago of interest rates, even after we strip out the impact of inflation, the result is still an interest rate. Here we're going to see that the units are going to be very different. So let me just introduce that very quickly, this idea. With a nominal exchange rate, or a nominal exchange rate, is the price of the, well, we've already said that, is we can think of this as the ratio of how much of one country's currency must be exchanged to buy a unit of the other country's currency. Okay, that's a nominal exchange rate. This is something we're very familiar with. How much of one country's currency must we exchange to buy a unit of the other currency? For example, $1.50 per pound. Classic example of a nominal exchange rate. Is a nominal exchange rate because it shows that it takes $1.50 to buy 1 British pound. So then what would be different about a real exchange rate? Okay, now this is something unusual, something we haven't seen before. A real exchange rate means unlike their nominal, which is a price of one in terms of the other, a real exchange rate is a ratio of how much of one country's goods must be exchanged to buy another country's goods. And so that's the key difference between the two. So this is one of the reasons why it's called real, because it's in terms of actual goods and services, for that matter, as opposed to simply currencies. So all of a sudden, the measure is trying to tell us how much of, let's say, American goods need to be exchanged for a certain set of British goods. Now, how do we figure out, though, what goods are being exchanged for each other? All right, well, let's do a little detour here. We'll introduce a brief discussion about how prices are measured in different countries throughout the world. We're going to introduce the concept of The price index is a number that represents the cost of buying a country's goods and services. For the US, one of the more popular or widely used price indices is the CPI, which stands for Consumer Price Index. Okay, so if you've had a macro class, you already know about this. CPI stands for Consumer Price Index. And what this means is that the government, specifically the Bureau of Labor Statistics, what they actually do in order to calculate this CPI is they go out and they actually go to stores and they price goods and services that they think Americans are likely to buy. In fact, what they've actually done in order to calculate this measure, what the government agency, by the way, that does this, that computes the CPI in the US, is known as the Bureau of Labor Statistics. Okay, so if you go to their website, you'll see that they have all this information available about how they calculate the CPI. So the CPI is based on what they call a basket of goods that is what they define this. This is what they call it, typically purchased during a given year by and they call this a typical urban family of four. So in other words, they have sat down and said, listen, let's try to figure out what a typical urban family of four might buy during a given year. And every year they go out and they determine the prices of those goods and they put those together into an index, which is known as the CPI. So that is a measure of inflation in the United States, specifically the cost of living. Now, there's other measures of inflation, but this is the one that directly impacts on consumers, the CPI. So it's really important, and you hear it all the time in the news. In fact, when you hear in the media them discussing the rate of inflation, typically what they're referring to is this. The rate of inflation in the US is often taken to be the percentage change in the CPI from one year to the next. Now, by the way, if you're curious to know what's in this basket, I can go show you a spreadsheet that I downloaded from the Bureau of Labor Statistics pretty recently. In fact, let me go find it. Let's see, I needed this for another class, and so I should have it right here. Here we go. So what you're going to see in the spreadsheet, it was downloaded from the Bureau of Labor Statistics website. And what they've done here, these are the goods that they're putting in the basket. And if you see, this is everything. And they break it up into several different categories, like food, for example. And then these are all the different kinds of foods. They break this up into food at home, which means you're cooking for yourself, of course, and then food away from home, which means restaurants or fast food places or whatever. Then they have energy. They have apparel, which is clothes, of course, vehicles, alcoholic beverages, tobacco, services, shelter, meaning rent, or whatever the case may be, medical, et cetera, et cetera. So you can see they have all these different items in here. And they also have what they call weights, which means, for example, here, the Bureau of Labor Statistics, according to their statistics, the numbers they have, people in the United States on average are spending about 14% of their budget on food. Okay, and then we break it down further into food at home, food away from home, and we break it down even further according to these different categories. With energy, we've got fuel oil, motor oil, fuel, gasoline, electricity. We have all these other items like clothes and new cars, etc. And so from this, you can get a sense of what people tend to spend in the US. And this is what we mean by the basket. This is the basket of goods that the BLS considers to be normal or standard in the United States. And the CPI is based on the prices of these items and these weights. And when they're done, they have a number. I think I have a copy also of the recent history of this CPI. I think this is it right here. And you can see, well, when it opens, here we go. It's a number. For example, right now, it's approximately 261.582. What does that mean? Well, they defined somewhere in the early 80s. There's a range of dates in here somewhere where they've defined this as essentially the starting point, or they call it the base year. All the prices that we see in this chart are based on these being the base year. In other words, 100 is the starting point. So when I see a CPI of 261.582 here, that means prices are about 2.6 times what they were in right here, let's say July of 1983, right in this range. Since that time, prices have gone up by about 160% compared to where they were in 1983. So you can use this information to calculate the rate of inflation from one year to the next. For example, let me do an example right here. Let's say I wanted to know what inflation has looked like over the last 12 months. So CPI in 2021, January 2021, the CPI is 261.582. The previous January, 1 year earlier, it was 257.971. So the inflation over that period would therefore be the percentage change, which means I need the new CPI. Oh, wait, sorry, this is a typo. This should have been 261. Sorry about that. So yes, in Excel, what I'm going to do is take the current CPI minus last year's CPI, divide it by last year's CPI. And this means that in the US, over the last year, consumer inflation has been approximately approximately 1.4%, which isn't that bad. I mean, that's fairly low. Ideally, we'd like it to stay or not rise too much above 2%. So right now, things are looking pretty good on the inflation front. We're only at about 1.4% per year. So historically, 2% or so has been seen as the highest you would really like to see it go. So we're a little bit lower than that, 1.4%. Okay, so the CPI is a good way of figuring out how much the cost of living is growing over time. And again, this number, the CPI itself, is referred to as a price index. It's a single number that represents the cost of living in the United States for what, again, is called a typical urban family of four. Now, as you can imagine, this is a very complex process to calculate this thing, but this is the one that we rely on. And when you hear discussions in the media about inflation or read about it on financial websites, this is what they're referring to, typically, changes in CPI from one year to the next. So now it turns out that there is a comparable measure in the UK. It's a similar idea, except it has a slightly different name. So in the UK, there is a similar price index known as the Retail Price Index, or RPI. Okay, so there's a inflation, the CPI is the American version, where we look at the change in consumer prices from one year to the next. and the British have a similar idea. Theirs is called the RPI. So those are the indexes that we're going to use to adjust the exchange rate between the dollar and the pound to convert it into a real exchange rate. Okay, so why don't we see some examples, and then hopefully it'll start to make some sense. Now, a lot of economists think that the real exchange rate is actually more meaningful as far as its impact on the economy as the nominal exchange rate. But of course, it's the nominal exchange rate that we deal with every day. So when you go traveling abroad, you don't pay for the real pound. You're paying the nominal price. And the question is, what does that suggest about your purchasing power in the United States versus the UK? So formally, we're going to define it in the following way. All right, so, wow, what is this all about? So we're going to use the letter Q to represent the real exchange rate. And now we've got three other terms that we have to define. So in fact, you know what I'm going to do? Let me copy this onto the next slide so we can think about all this together at the same time. There we go. Yeah, so we can look at the definitions while we're looking at the formula. There we go. So Q is the real exchange rate. E will be defined as the spot exchange rate. P will be the domestic price level. And P star will be the foreign price level. All right. So let's assume that we're dealing with the dollar and the pound. And so if that's the case, then remember the spot exchange rate would be dollars per pound. And then the P would be the CPI in the United States. And by the way, every country has their own version of the CPI. Okay, it's not just the US and the UK. If you wanted to calculate the real exchange rate, let's say between the dollar and the yen, you would go through the same thing. You would look at the US price level, the CPI, and then you would look at the Japanese equivalent of that, which I don't know the name of, but all countries have some version of this. And you would be able to use that to convert it into the quote real exchange rate. And so first of all, let's see how that would work with some examples, and let's try to understand what it means. So here, for example, just to expand on what we just said, we have P as the US price level, which in our case is the CPI, okay? It is the price of a representative basket of goods and services based on, what the basket that was chosen by the BLS. And so that's what we're going to use as the US price level. P star will be the UK price level. All right, so remember, P is the US level. P star means the UK or foreign price level. And that's going to be the RPI. So this way we can define formally what the baskets of goods are in each country, which, by the way, the baskets are not likely to be identical to each other. All right, the things that Americans buy might be different than what the British buy. Or even if not, then certainly the weights are likely to be different. But that doesn't matter, okay, as long as we know how much each basket is worth and what's in each basket, we can formally define the real exchange rate. Now, the real exchange rate, as we've already seen, can be thought of as the quantity of US goods and services that are required to obtain a given quantity of UK goods and services. So, and again, the nominal exchange rate is all about how many dollars does it take to acquire a certain number of pounds. So you can see the key difference here is that real is measured in terms of goods and services. Nominal means currencies or money. All right, now let's look at a numerical example of this. Okay. It's not that involved mathematically, but it's kind of an odd concept. We haven't really seen this before, so it's a little bit involved. But let's just say in our example that a representative basket of consumer goods in the US, just to keep it simple, cost $100. That's the basket that is priced by the US Bureau of Labor Statistics to calculate the equivalent basket in the UK cost 80 pounds. Okay, so their basket cost 80 pounds. And then the spot exchange rate between the dollar and the pound is $2 per pound. And again, we're doing this just to keep it simple. Then how do we calculate the real exchange rate? All right, well, we saw the formula a few minutes ago. Let's remind ourselves what this is equal to. All right, I'll just sneak it up here somewhere so you can see what's going on. So we're going to plug in some numbers. E is the spot exchange rate, $2 per pound. P star is the cost of the British basket. And the US basket cost $100. By the way, when we're done with all this, all of the units, the dollars and pounds will drop out. The units will be the number of US baskets that are needed to buy one UK basket. All right, you'll see in a second, don't worry. So you can simplify this now by multiplying through here. If you notice, $2 per pound times 80 pounds per UK basket means that it will cost an American $160 to buy this basket. And of course, the US basket at home costs $100. So if you divide these out, you'll wind up with 1.6 US baskets are required to buy one UK basket, or the real exchange rate is simply 1.6. All right, the nominal was $2 per pound, but the real exchange rate is 1.6 US baskets per UK basket. So again, you see the emphasis is on goods and services instead of dollars and pounds. So it's a very odd concept, but that's how it works. Okay, so real measures baskets of US goods per UK basket. Nominal, as you know, is dollars per pound. All right. Now, just like spot exchange rates, or I should say nominal exchange rates, can appreciate or depreciate, same thing can happen with the real exchange rate. Okay, we can have both. What's different now is that this can be caused by different reasons. Okay, so let's take a look at some numerical examples. Now, with real exchange rates, these changes are going to tell us how competitive a country's goods and services are in world markets. Okay, because again, the focus is on goods and services. The question is, how attractive are US goods in the world markets compared to UK goods? All right, so let's see how this works. All right, now let's look at an example. Based on what we just did a minute ago, where we had the US basket cost $100 and the UK basket cost 80 pounds, and the spot exchange rate is $2. All right, so let's remember those numbers. But now let's assume that a change happens. The US basket drops from 100 to 80, whereas the other prices remain the same. The UK basket is still 80 pounds, and the nominal exchange rate hasn't changed either. All right, let me actually sneak this in here. From 100 to 80. So all of a sudden, the US basket is cheaper. Now, in practice, that should improve our trade balance, wouldn't you think? Well, we're going to think in the terms of the real exchange rate as whether or not US exports will become more or less attractive. So let's do the math again, just like before, except what's different is down here, the denominator is $80 instead of 100. So we've got a smaller denominator, so it stands to reason that the ratio will go up. All right. And that's exactly what happens. All right, let me just give you a minute to catch up. So, all right, so what does that leave us with? Well, in the numerator, you can see by multiplying those numbers out, we still have $160 per UK basket in the numerator, but now we're dividing it by only $80 per US basket in the denominator. So you can see, I mean, you can do this in your head. Clearly, the real exchange rate is now going to be not 1.6, but 2, all right? So there's this ratio, 160 per US basket, or UK rather, divided by 80 per US basket, means that the ratio becomes 2, which means we have to trade 2 baskets from the US to get 1 basket of UK goods. So you might say to yourself, well, what's going on here? What does that suggest about our exports? Good question. Well, let's think about this. Since Q is now 2, or it has risen from 1.6 to 2, this means that US consumers have to pay 2 US baskets to buy 1 UK basket instead of 1.6. Whereas UK consumers only can trade 1 UK basket for 2 US baskets instead of only 1.6. So what do you expect to happen to our trade balance? All right. Well, you know what? Why don't we turn this into a poll? Let's do that. If the real exchange rate rises like we did here, what should happen to the US balance of payments? Or in other words, the trade balance? Well, there's really 3 possibilities. It improves, it worsens, or the third possibility is that it is not affected. So in there is a possibility. So let's find out. What do people think about that? Ooh, people are reluctant to vote. All right. Well, these choices are neck and neck. Well, I'll tell you what. It turns out that it improves. So 38% of you are absolutely correct. Oh, 41% of you are absolutely correct. I think somebody voted after I said that, but that's okay. So why? That's the big question. Well, even though we're no longer dealing with dollars and pounds, when you stop and think about it, that means that in the United States, British goods have become more expensive. In the United Kingdom, American goods have become cheaper. So the natural result would be that, let me just add this here. So in the US, British goods have become more expensive. Okay. In the UK, yes, in the UK, American goods have become cheaper. Okay. Therefore, Americans buy fewer UK goods or fewer British goods. The British buy more American goods. And the result is that the US trade balance improves. Okay, so if you recall, when we were looking at nominal exchange rates, the same thing happened when the dollar got weaker. Okay, we had examples like this earlier where we saw that if the dollar gets weaker or depreciates, then we have an improved trade balance. Well, the same thing is true here. So let me just mention that down here. So what we're going to do here is make the following claim. If the dollar depreciates in real or nominal terms, the U.S. trade balance improves, which implies, of course, the opposite too. If the dollar appreciates in real or nominal terms, the U.S. trade balance, of course, worsens. So in other words, in that respect, what we're doing here is no different than what we did with nominal exchange rates. Okay, so a depreciation means that our goods will sell better abroad and we'll buy fewer foreign goods, so the trade balance actually improves. If the dollar gets stronger in either real or nominal terms, the US trade balance actually gets worse. So we can make the claim then that when US goods are cheaper, they're actually what we're going to call more competitive in world markets, which means that they're more attractive to foreigners, whereas foreign goods are less attractive in the United States. Therefore, we have what we call a real depreciation, and our trade balance will improve as a result. Okay, now let's look at the opposite case. Well, I'm sure you can see where this is going. If we've experienced here in this example a real depreciation, now let's see what happens if there's a real appreciation. So here, what's happening is that the US basket suddenly goes from 100 to 160. The UK basket stays at 80 pounds. The nominal exchange rate stays at $2. Let's see what happens to the real exchange rate. Now, before, remember, it went up from 1.60 to 2. What do you suppose is going to happen now? Well, let's find out. So we've got $2 per pound. So this hasn't changed, but here's what's different. So we're dividing now by a larger denominator. And so if you look at this ratio carefully, you'll see the numerator is now $160 per US basket. The denominator is $160 per US basket. So I think you can figure out in your head what that ratio is going to be. And of course, it is 1. Which means now, as Americans, we're happy in the sense that we only need to trade one of our baskets to buy one of their baskets. Okay, so is that good or bad? Well, it depends on what side you're looking at. If you're the buyer or the seller of these goods. So here, we can say then, you know what this means though? US goods are more expensive to UK consumers. UK goods are cheaper in the United States. Okay, so therefore, guess what's going to happen? US goods are less competitive. This is a real appreciation. But what is the impact on our trade balance? Okay, let's find out. All right, so once the dollar appreciates in real terms, US goods are more expensive in foreign countries. UK, well, all right, in the UK, and UK goods are cheaper in the US. Therefore, the US trade balance will weaken or worsen, I guess we could say. All right, and again, this is no different than what we saw with the nominal exchange rate. A stronger dollar means that our goods are more expensive to foreigners and their goods are cheaper to us, and therefore our trade balance will get worse. Well, so what we're going to do now is summarize this a little bit, just to remind ourselves what is going on. What is the relationship between our trade balance and the real exchange rate? So just like, all right, well, this is just a quick summary. If Q rises, that represents a real depreciation. And that means our goods are more competitive in world markets, which means that our trade balance should improve. But of course, if the opposite happens, in other words, if Q falls, all of these factors will be reversed. Okay, in other words, watch this. If Q falls, the dollar has experienced a real appreciation, and therefore our goods are less competitive, and we will have a larger trade deficit. Okay, now, I said before that there's now different ways in which this can happen. If you look at the formula, let me just go get it back again. The formula for the real exchange rate, let me go grab it from up here somewhere. Here it is. You'll see that there we go. So now remember, a depreciation in real terms means a higher level of Q, or Q increases. As a result of 3 possibilities, the dollar could depreciate in nominal terms. In other words, if E goes up, then with no change in the prices, then Q also has to go up. But if British goods go up in price, that will have the same effect. In other words, Q will go up. But keep in mind that means our goods have become more competitive. And if our goods become cheaper, that means you have a smaller number in the denominator, which means Q goes up. So you've got 3 ways in which the dollar can depreciate in real terms, all three of these result in a stronger trade balance. All right, so unlike with the nominal exchange rate, if it either goes up or down, but here you can see that the real exchange rate is affected by not only the nominal exchange rate, but domestic and foreign prices. So in fact, since these factors can all change at once, you could actually have a stronger dollar in nominal terms and yet a weaker dollar in real terms. It could happen. Well, now we're going to look at the opposite case, of course. The dollar can appreciate for three different reasons. All right. And this time it could be caused by nominal appreciation of the dollar, lower prices in the UK, and higher US prices. Okay. And again, all three of these cases result in a weakening trade balance. So, and that makes sense because if US prices go up, of course our goods will be less attractive to foreigners, and we should expect to have a worse trade balance. Okay, so that's what this is all about. So now again, it's not just the exchange rate here, the nominal exchange rate. We're looking at prices as well. All right. Now we're going to delve into a very, very interesting area here. We're going to introduce a concept which you see in all financial markets, not just foreign exchange markets. And that's this notion of something that you may have seen before. And I'm going to write down this word, and you're going to see that it's a very impressive looking word, but the question is, what does it mean? And so that word is actually a French word. And what is that magic word that I'm thinking of? That word is arbitrage. My God, what does that mean? Well, arbitrage is an opportunity, or an arbitrage results when it is possible to earn profits without taking any risks by buying a relatively underpriced asset, selling a relatively overpriced asset. And so the difference represents arbitrage profits. Now, that's a strange idea. The idea that you could actually buy something that's too cheap, sell something that's too expensive, and put money in your pocket. Now, in practice, keep in mind, this isn't going to happen unless markets are inefficient. Now, markets at this point in time are, of course, highly efficient, but not perfectly so. They never can be. Markets can never be perfectly efficient, but they're very, very efficient. So this isn't likely to happen very often. So why don't we take a quick look at an example of how this could actually happen in the foreign exchange markets. For example, suppose, just to keep it simple, that the exchange rate between the dollar and the pound, by the way, we're back to nominal exchange rates now, between the dollar and the pound is, just to keep it simple, $2 per pound. Obviously, it's nowhere near that level right now. Now, we also find out the price of gold in the US is, let's say, $1,600 per ounce. The price of gold in the UK is, let's say, $700 pounds per ounce. Does this represent an arbitrage opportunity? Okay, well, the answer is yes. The question is why? Why is this an arbitrage opportunity? Well, here's what we're going to do. We're going to convert the price to dollars in both countries. So the gold price in the UK can be expressed in dollars. All right, so remember, it was 700 pounds per ounce, but the exchange rate between the two currencies was $2 per pound. So you know what that means. The price is $1,400 compared with $1,600 in the US. Well, something's out of whack. How can gold be so cheap in the UK and so expensive in the United Kingdom? Well, the answer is it can't. These markets are inefficient. They're inconsistent with each other. So a trader can do the following. And let's just say that they decide to do this 1 ounce at a time. Borrow $1,400 and buy gold in the UK for $1,400. Sell the gold in the US for $1,600. Pocket the difference. Well, they have to repay the loan, but pocket the difference of $1,600 and then repay the loan of $1,400. And so you can see the nice thing about this is that this, let me move this to another slide, by the way. This provides the trader with a risk-free profit of $200 per ounce of gold. Okay, now we're assuming that all this takes place very quickly so that prices don't have time to adjust. But just because of the mere fact that the gold price was different in the two countries made it possible to make money by exploiting the difference in the prices in the two countries. So this is known as an arbitrage profit. Since the trader earned $200 without investing his own money or taking any risks. Now, if we can do this with 1 ounce of gold, what's to stop us from doing this with 1,000 ounces of gold or 1,000,000 ounces of gold? The answer is nothing. Now, is there a limit to this process? Of course. The opportunity will disappear very quickly because as gold is purchased in the UK at $1,400, well, actually, what I should say is 700 pounds. And sold in the US for $1,600. The price will rise in the UK and fall in the US until they're equal after taking into account the exchange rate. Okay, so in other words, this process will take care of itself because people will see this. They'll all jump in and start buying gold in the UK, and they'll start selling gold in the United States. And before you know it, the prices will adjust themselves until the opportunity is gone. Now, in this day and age, of course, this kind of thing is highly unlikely to happen in practice. But what still can happen is for trading, let's say, not so much gold, but financial securities like stocks and bonds, opportunities like this could occasionally arise, but they disappear very quickly. So what happens is that there are places called hedge funds. Let me just throw this in here. A hedge fund, we may have heard of them. A hedge fund is set up to try to earn very large rates of return with risky strategies. Now, there's a particular type of hedge fund, a statistical arbitrage fund, is set up to find arbitrage opportunities. Okay, so if this happened in the real world right now at this point in time, what can happen is these funds what they're doing is they have enormous computer power at their fingertips. These funds will have massive amounts of computer power, which is used to find even very small discrepancies in market prices, and then take advantage of these to earn arbitrage profits. These discrepancies often last for only fractions of a second, so that only computers can take advantage of them, not human traders. So really, it's getting to the point where only computers can look and find these opportunities, because they don't last very long if they ever do show up in the first place. So imagine you're working at a hedge fund and you've got massive computers running around the clock, looking at every market in the world and trying to find these small discrepancies that might show up even for just fractions of a second. And then the computer actually is programmed to jump in and buy and sell what it needs to do to make a profit. So it can be done even now when markets are so efficient, but it's a very risky thing. It's a very risky process, and it requires a lot. Now, here's the problem with this, though. From the perspective of the hedge funds, is that often these trades result in small profits. So the hedge funds make up for this by using large amounts of borrowed funds to make the trades. That's where the risk is, because if everything is successful, these trades can be extremely profitable. If not, they can result in huge losses. It's like, imagine yourself borrowing, that, let's say Bitcoin is worth about $60,000. Suppose that you decided you want to invest in Bitcoin, but you don't have any money. So you borrow $60,000 from the bank and buy a Bitcoin. What could possibly go wrong? Well, what happens if Bitcoin goes down in value and you're forced to sell it at a loss? Well, that's a loss. That you don't have that money. It's not your money. You borrowed it. You have to pay back the full $60,000, no matter how much the Bitcoin is sold for. So it's a terribly risky position to be in. And so the hedge funds themselves are very risky. And so they can be very successful, but a lot of them go out of business. In fact, something like a third of them go out of business every year because they can be wiped out very quickly by even small changes in the market. So it's a very dangerous thing to be doing, but they're out there because there's a demand for their services. There are always going to be people who want to gamble. Gambling is fun. It's exciting. It can be very lucrative. So if an investor has enough money to gamble with, they'll approach a hedge fund and have them set up one of these strategies. And this is how they make their money. So anyway, but in general, arbitrage is very difficult because markets are so efficient. This kind of thing could never happen if markets are perfectly efficient. All right. Now, in the foreign exchange markets, rather, there's two specific kinds of arbitrage that you only see in these markets that we want to focus on now. So the first one is something that the name is very cool sounding. It's called triangular arbitrage. Now, this involves, as you can imagine, three different currencies that, if they become misaligned with each other, then we could take advantage of this and earn arbitrage profits. Now, this arbitrage specifically involves what we call cross exchange rates. You might recall from way back in the beginning of this chapter. Let me go get it for you. It's been a very long chapter, so but I just want to go quickly remind you what this is all about. Okay, cross exchange rates. Let's find them. Just as a quick review, this is a cross exchange rate. Why? Because it does not involve the dollar, but it is calculated from $2 exchange rates, the rate between the yen and the dollar, and the rate between the dollar and the pound are combined to give us a quote between the yen and the pound. So what we're looking for here with triangular arbitrage is opportunities to take advantage of mispricings. And what we mean by that is, imagine if, given this information, you found a foreign exchange dealer that's willing to sell you pounds for 150 yen each. Well, you know that it should be 149.3805. So when that happens, you can earn a profit because the dealer is giving you a bad quote. The problem is we have to figure out how to take advantage of this situation. So in other words, if an actual quoted cross exchange rate is inconsistent with this calculation, whether it's too high or too low, a smart trader can take advantage of this and earn arbitrage profits. Now, this whole thing is going to seem like a very complicated setup, but once we've done it a few times, you'll say, oh, it's not hard at all, because it really isn't. But it does take a bit of setting up and a bit of getting used to. All right, so what do I mean by that? All right, let's see what's going on here. Suppose we had the following scenario. In New York, the dollar-pound exchange rate is quoted at $2 per pound. In London, we have a dealer that's giving us a quote of 250 yen per pound. In Tokyo, the exchange rate between the dollar and the pound is currently 120 yen per dollar. Now, it may not be obvious immediately, but these three numbers are inconsistent with each other. And therefore, we should be able to earn arbitrage profits by exploiting this difference. But how? Well, first of all, let's prove that there is an inconsistency. How do we do that? Well, what we're going to do is take these two quotes and consolidate them to see what the implied cross exchange rate is between them. In fact, why don't we, let's see. There it is. So if I took those two quotes and I can combine them, you can see that the cross exchange rate should be 240 yen per pound. But somehow this other dealer in London gave us a quote of 250 yen per pound. So clearly there is an arbitrage opportunity here. And now here's the nice thing about arbitrage. Well, it's not nice necessarily, but if I make, let's say, money from this trade, the dealer who gave me the bad quote is going to lose money. So my profits come at his expense. And so we're hoping that this dealer in London doesn't get fired because they're going to cost their firm a lot of money. But how do we do this? We're going to set up a diagram, a very interesting looking diagram to see how this works. We're going to assume that a New York trader notices this discrepancy and has access to $1 million. Let's say this trader works for a major brokerage house like Goldman Sachs. They notice this discrepancy and they take $1 million of the bank's money and they do the following. Here we go. Here's our US dollars. Now, you notice what we've got here. We've got a triangle consisting of three currencies. The dollar, GBP stands for Great British Pound, or Great Britain Pound. JPY stands for Japanese Yen. So what exactly are these numbers telling me? All right, so remember, we did say that we're starting with $1 million in the United States. And remember the quotes we were given, $2 per pound, 250 yen per pound, and 120 yen per dollar. So if I start with $1 million in the United States, I can convert those into pounds. And by doing that, if you notice, $1 million divided by $2 per pound is going to give me 500,000 pounds. Okay, 500,000 pounds. So I'm basically going to the dealer in London and trading my foreign exchange dealer, that is, my $1 million for 500,000 pounds. Now I'm going to approach that dealer who gave me this bad quote and say, listen, you offered me 250 yen for each pound that I deliver. I would like to take advantage of that, please. And so what's going to happen is you're going to take 250 yen per dollar, or per pound rather, and multiply that by 500,000 pounds. And that's going to give me 125 million yen. Okay, so far I've traded $1 million to get 500,000 pounds, which I then traded for 125 million yen. Now, how do I convert those yen back into dollars? I use the quote of 120 yen per dollar. This time I have to divide though. And it turns out that when you do this division, and you can double check this with your calculator, you're going to wind up with $1,041,667. Now, in the past, this would have required a bunch of phone calls. This trader did all of this from the console in front of him, where he punched in a bunch of buttons and bought and sold, and this all took place in a matter of seconds. All of a sudden, $1 million became worth $1,041,667. Well, how did that happen? The arbitrage profit is the difference between the two Not bad for a few seconds worth of work. Probably get a big fat bonus at the end of the year. Now, who's losing this money right here? This dealer over here in London who gave us the bad quote. Wow. And it was that simple. It's a three-way relationship that has to hold. Otherwise, there's an arbitrage. Now, had the dealer given us the right quote in the first place, let's replace this with 240. You'll see that right here, we would have divided, this would have been 100 and, actually, let's put it here, 120 million yen. And when you do this math, you'll see that you would have ended up with exactly $1 million, which means no arbitrage profits. It's that extra 10 yen per pound that's generating these profits. Wow, that's scary. It didn't take much. Now, of course, like we saw before, this cannot last for very long because everybody else in the market will see it and start making these trades. And before you know it, this cross exchange rate will have to move back to its correct level. Okay. All right. So this is an example. Now, obviously, this is much more complicated than the gold example, but it's the exact same principle. You're buying something that's too cheap and you're selling something that's too expensive. It's harder to see that relationship with three items, but the bottom line is as long as this cross exchange rate is inconsistent with these two rates, you know that there's an opportunity there for you somewhere. Now, let me ask you this question. What if I'd gone backwards in this triangle? What if I took my dollars and used them to buy pounds and my pounds to buy yen? If I took my dollars and bought yen, and then I used the yen to buy pounds, and then I used the pounds to buy dollars, what would have happened? Does anyone want to guess? Nobody wants to guess? Oh, I think it should be pretty clear what's going to happen. What's the opposite of a profit? Here we go. A loss, exactly. So I'm going to show you exactly how that would have worked. So let's go back here and see what if let's say that's our first day in the job and we know that there's an opportunity here, but we got it backwards. So we started with our $1 million, we convert them into yen. So we have $1 million multiplied by 120 yen per dollar. That gives me 120 million yen. With my yen, I go in here and I buy pounds. So here I'm dividing. And guess what? Oh, sorry, not per dollar, per pound. What does that leave me with? Oh, you see, there's the problem. Remember before when we went in this direction, we had 500,000 pounds. Now, all of a sudden, we only have 480,000 pounds. So when we bring those back to the US, we're going to have a big problem, aren't we? Of course we are, because now look what happens. If I take my 480,000 pounds and divide them by $2 per pound, I'm only going to wind up with, oh, sorry, my mistake. This is multiplied. Of course it is. $2, here we go. Yeah, let me do that all over again. My 480,000 pounds is multiplied by $2 per pound because I want to convert them into dollars. And guess what? That leaves me with only $960,000. I started with $1 million and I ended up with 960. I made $40,000 disappear So my arbitrage loss, or I should call it a trading loss, because I haven't really committed an arbitrage, is $40,000. I screwed up. I'll probably get fired now as a trader and I'll do something else. Maybe not. But you can see you have to understand what to do with these opportunities. You have to know which currency to buy and which one to sell. Otherwise, you're bound to make a terrible mistake. But on the other hand, the good thing about this is that if you do go around the circle and you find a loss that you've made, that means you just have to reverse the circle, or I should say triangle, and you'll end up with the right amount. Okay, so in other words, imagine yourself in a test doing this, getting this backwards and noticing you've got a loss. Then all you would have to do is reverse the direction and you'd find yourself with a nice little profit. Okay, a nice little profit. So that's, yeah, I mean, if one direction loses you money, the other has to make you money. And again, in all cases, if the cross exchange rate is correct at the right level, then you will have no profits no matter what direction you go in. All right, well, that was pretty complicated. Don't worry, we'll get plenty of practice with these. Now, I do want to point out, though, that it wasn't necessary to start with dollars to make money here. Let me just quickly show you the other two scenarios where we started with pounds and we started with yen. All right, so anybody in these three countries can make money. It's not just Americans. Let me show you this case. What if I started with pounds? I'm going in the same direction. And when I'm done, you can clearly see that I made a profit, a nice tidy little profit of 20,833 pounds and 50 pence. As long as this bad quote stays in place, it doesn't matter where I start, but it does matter what direction I go. So if you notice, the British trader is also going around in this direction. All right, you can't switch that. The starting point is irrelevant, but the direction does matter a great deal. Okay. And then, what if I started with yen? Would I have made money? Yes, I would have. Let's see how much. Let me just jump ahead and show you the final results. Let's say I started with 125 million yen in Japan, and I go in this direction. Well, look what happened. I finished up with a profit of 5,208,375 yen. So any way you look at it, I'm going to make a profit. All right, so that's kind of all we need to say here. What I would like to do, though, is get some examples together so we can practice with this, because it is a very complicated idea. We just seen the tip of it. We want to really understand how this works. So I'll tell you what, why don't we stop it here, because the next topic is even more complicated. And what we're going to do next time is we're going to work on some of these examples, and then we can carry on with the next type of arbitrage, which involves spot and forward exchange rates. Okay, so instead of cross exchange rates, this will involve the relationship between spot and forward exchange rates. All right, so I guess it's Monday. Yeah, we can stop right about here and kind of call it a day from school. I hope that this is your last class, and then I'll see you all on Thursday.
Bye, Professor.
Thank you.
All
All
right,
right.
later.
Everyone enjoy your days.
Okay, bye everyone.
Bye.